where t is an element of real numbers. We know that r naught is our position vector, and we know that t is a scalar, and ABC is our direction vector, okay? The parametric equations, that's when you solve for x, y, and z. So x would equal x naught plus at, y would equal y naught plus bt, and z would equal z naught plus ct. So right from here, okay?
Oh, Miss.
Yeah.
Last time, didn't you tell us that t couldn't equal 0?
Yeah, I did. No, t can never equal 0. Never, ever. T can never equal 0, but we don't have to state it. But what I do want you guys to state always when you're writing your equations is t is an element of real numbers.
Then how do we ever get the position? So like we would never get like x naught, y naught, and z naught as like a coordinate.
Why not?
Well, because t wouldn't equal 0, so it would always be like x naught plus at. Like we would never get just x naught.
Oh, I see what you're, well, no, you're saying if it's just a point, like you would never have just where it's just your position. No, you wouldn't.
Okay.
Right? It's always plus a scalar. Right? Always plus, sorry, your direction vector times a scalar. Right? Because you got to get up on that line. Correct?
Yeah, thank you.
Okay. All right. So now, solving each equation for t. So this is how we get what are called symmetric equations of a line. So now we're just going to solve for t in each of these. So t would be equal to x minus x naught, and then we divide by a. And then we look at t in the next equation, and it would be y minus y naught divided by b. And then you have z minus z naught divided by c. But Hey guys, sorry, I was teaching to nobody. I don't know, it pushed me out, but it doesn't show me because I'm on my other screen. So anyways, let's try this again. Oh boy. How far did we get?
Not very.
We
Oh,
were still on the first slide.
okay. Okay, let's go back. So still on the first slide. You guys are all with me, yes?
Yep.
Okay.
Yep.
Yeah.
All right, so we got through all this? Symmetric equation.
You
So-
were saying something for the bottom part, and then it cut off.
Okay, thank you, Nicholas. So here, A, B, and C cannot be zero in order to get your symmetric equations. If A, B, or C is zero, then you can only find your parametric equation. You can't find the symmetric equations. Okay, that's all I was saying here. So what we're doing here is we're solving for T, and we know that T has to be the same in all of them, right? So that's how you get your symmetric equations. When you write the symmetric equations, we don't put T equals. We just write them like this. Okay? And we know T is an element of real numbers. Okay, so example 1. So here it said, a line passes through the points P and Q. Determine two vector equations for the same line. So here you have so many different options. So I started off by finding the direction vector for PQ. So the direction vector for PQ is 5 take away 2, 0 take away 4, 7 take away 0, 3, negative 4, 7. And I picked one of the 2 points and I used that direction vector and that gave me my R1. Now for R2, I didn't have to find another direction vector. I could have just used 5, 0, 7 and the same direction vector, but I wanted to show you that I could also find a second direction vector, and it's just the direction vector going in the opposite direction, which is negative 3, 4, negative 7. Okay, and I used that for my second, but I didn't have to. Okay, are there any questions? And notice, guys, uh-oh, I think we might have problems today, guys. Let's try this again, okay? If this doesn't work, if this keeps happening, I'm just gonna post the recordings, okay? But let's try to get through this. You guys can hear me, yes?
Yeah.
Okay,
Yeah, we can hear you.
okay, let's try this again.
Can you hear us?
I can hear you, yes, I can hear you guys. Okay, so how far did we get here, guys? Was I able to explain all of A?
Yeah.
This one? Or B?
We gone for like B.
B, okay. So here, determine the parametric equations. So R1 is equal to 2 plus 3t. X is equal to 2 plus 3t. I'm taking it from R1, okay, my first line. Y is equal to 4 minus 4t, and Z is equal to 0 plus 7t, or just 7t. Okay, comma t is an element of real numbers. Now I want the symmetric equation, so you just have to solve for t in each of these. So I have x equals 2 plus 3t, and I solve for t. X minus 2 divided by 3. Y minus 4 divided by negative 4. Z divided by 7. Do you guys see that? We're just solving for t, and this is how we write the symmetric equations. We just set them equal to each other. T is an element of real numbers. Are you guys still with me?
Yep.
Oh,
Yeah.
excellent. Okay,
Yes.
thank you. Okay. does K lie on the line? Well, if K lies on the line, we've done a question like this before. We just we didn't check using symmetric equations, not formally anyways. But if we want to know if K lies on the line, we just have to make sure that T is the same. So we solve for T by subbing in the point K. So I sub in -4, 12, -14 respectively in the equation. And I see that T equals -2 for all three. And so therefore, yes, it lies on the line. Okay, if the T's were not equal, then that means that point is not on the line. You still with me?
Yep.
Oh, okay. Okay, sorry, I almost had another little mini heart attack. Okay, are we ready to go to the next example? Okay. Example 2. Determine a vector equation for each line. And sorry, the arrow there is on the equals. I don't know why it's shifted over. So passing through the point -3, 5, 7 and parallel to this line. So if it's parallel to this line, what can I use from this line to help me?
The direction vector.
Excellent, because essentially that's like our slope, right? So that means if they're parallel, then they're going to have the same direction vector. Perfect. So what I can do now to get my equation is just use my new point, because the line passes through this point.
Third time's the charm, miss.
Okay, so this time we're going to be good, right? It's okay, I'm just going to keep logging back in. What can I do? But at least I can hear now, so it gives me a little noise when it logs me out. You know the same little noise when somebody leaves a message in the chat? It does that, so I kind of know now when it's logging me out. I've realized it's not someone writing in the chat, it's logging me out. Okay, we can try this again. I want to present my screen, so let's do this again. Okay, let's see if 3 times really is a charm. Okay, so passing through this point parallel to that vector equation of a line, and so we use the same direction vector. Okay, parallel lines have the same direction vectors, and I use the point given because we know that it passes through the point. Now, passing through the origin and perpendicular to the YZ plane. So I have a little diagram here. So if we're perpendicular to the YZ plane, I want you to imagine the vector coming straight out at 90 from the YZ plane. I'm going to try to draw it. I'm not very good, but can you guys see that? It's coming straight out, so it's forming like 90 with the YZ plane. So in order for it to be normal with the YZ plane, what type of a point does it have to be? Because if we lie on the YZ plane, then this would be an example of a point that lies on the YZ plane. X is 0, right? Any point where X is 0. So if I want to be perpendicular to the YZ plane, what would a point be? Anyone know? Are you guys still with me?
Yeah.
Okay. Okay. Does anyone have any idea? So take a look at that line that I drew. Do you see how it's parallel to the x-axis? Do you guys see that? So any line that lies on the x-axis would be perpendicular to the YZ plane. So I'm going to use just the simplest point, right? And I'm going to use 1, 0, 0 as my direction vector. Does everyone follow? Because we're perpendicular now. Okay, passing through the origin. So if it's passing through the origin, what's the point that I need to use?
0, 0.
Yes, 0. And so this is my equation. Okay, so I'll say it again. If you're lying on the YZ plane, that means that your X coordinate is 0. If you want to be perpendicular to the YZ plane, then that means you're on the X axis. Okay, so any point that's on the X axis, or any vector then that is on the X axis, would be a perpendicular direction vector, would have a perpendicular direction vector. Okay, having parametric equations of X equals 3 plus T, Y equals 5T, and Z equals -7. So now I want to come up with my vector equation. What should I do?
Find a point and a direction.
Okay, good. So let's get the position vector. So what's the position vector? Which means, yes, our point, right?
3, 0,
our position?
-7.
Excellent. You should be able to look at this and see that it's 3, 0, -7. Okay, because I have 3 plus T, 0 plus 5T, -7 plus 0T. Okay. All right. What's my direction vector then?
1, 5, 0.
Yes. Excellent. Okay. Remember, our direction vector is always multiplied by T. And so now we can just write this as first our position vector plus T Cool. Are there any questions? Okay. You guys are still with me?
Yes.
Yeah.
Excellent. Okay. So now I want to write symmetric equations for this. I want to write symmetric equations. So these are sort of, they kind of already look like symmetric equations. Sorry, excuse me. I want to write a vector equation given this symmetric equation. So from here, how can I rewrite this to maybe help us identify what's going on here? Anyone? Okay, well, we're used to seeing them like this. This is going to help us see the direction vector better. So now when I look at this, what's the direction vector? One, negative 1, 1, yes? You're still with me?
Yes.
Okay, and what would my position vector be? Can you guys see it? What would the position vector be?
1, 3, 0, -1.
3, 0. Careful. It's my fault. Do it again.
3, 0, -4.
There you go. 3, 0, -4. If you're having a hard time seeing this, then what you can do is this. We know that x minus 3 equals t. Go ahead and solve for your x. And see, that's how you can see that your position vector starts, it's a 3. It's the opposite, right? Because we brought it over. Okay, and the same with the negative y. And with the z. Okay. And there's our vector equation from the symmetric equations. Okay. Any questions? You guys are still with me?
Yep.
Yes.
Excellent. Okay, good. Hey, maybe 3 times this term. Okay, example 3. So just so you guys know, here, it's like this. It's a cursive L. Okay. All right. Determine if the lines are coincident, parallel, or perpendicular, or none of these. So what does coincident mean? When we use the word coincident with
Same.
reference to lines. Yeah, same line. Excellent. When we say parallel, what does that mean?
Same slope.
Same slope, or in this case, same
Direction
direction
vector.
vector. Yes, excellent. Very good. Or a direction vector, that's a scalar multiple, right? Excellent. Okay, perpendicular or none of these. So let's start. If it is coincident, then it automatically has to be parallel because the direction vectors have to be the same. So let's check direction vectors. What is the direction vector for my first line? Can you tell by looking at it? It's right here. That's our direction vector. Okay, and from here, we see that it's -3 to -1. What do you think? I think they're definitely parallel. Yeah. Right? Scalar multiple, right? Good. So I know now they're definitely parallel, but are they coincident? How can I check if they're coincident?
If the points are multiple of the direction vector.
If the points are multiple, okay, yes. So how about, how can I check algebraically? You're right, I understand what you're saying. How can I check algebraically? So I'm basically saying, is 4, 3, -1 on that line? So having said it this way, does that trigger something? What does that mean? What are we going to check for?
T value.
Yes, we're going to check to make sure that the t values are the same. So if I'm checking the t values, I'm going to check from symmetric equations, which I have. Do I need to, okay, well, let's check. Let's do these and see what happens. So subbing in 4 minus 2 divided by 3, I get 2 over 3. Over here, I have 3 plus 5 divided by -2, and I get -4. So what do you guys think? Do I need to go any further? The t's are not equal. Do I need to check the third one?
No.
No. If these two were equal, then I would have to, but they're not, so I don't need to continue. I can automatically say now that line 1 and line 2 are parallel, but not coincident.
Miss.
Yeah,
So to recap, what you did was you plugged in the position of line 2 into line 1.
I did.
Okay, thank you.
Yeah, because I want to check if, and I could have done it the other way, right? I could have subbed in the other, my other points in the other line. I didn't have to do it this way. I just want to check that they're on the same line. Okay. Good. And that's it for this section. So your homework is page 449, 1 to 12, omit 8B, 14 and 15. So let's just take a short break. So it's 1:04 on my laptop. So let's convene or reconvene at 1:10. Let's say 1:10, and then we'll do the second part of this lesson, okay, or 8.4. Cool?